Hey everyone, this video is going to be about some different variations. The first one is direct variations. So I want you to take a look at this table and notice what we do to the x to turn it into the y. If you'll notice, each of the x values gets multiplied times 4 to get the y values. If that's the case, then the equation for the direct variation is y equals 4x. That's what we call a direct variation. Here are some examples of direct variations. So take a look at these equations. They all are y equals a number times x. Could be a fraction, that's fine. Could be negative, that's fine. So when you graph those, notice that for each one of these, you get a straight line. And all of those lines go through the origin. Every single one. And that's because if I were to write those in slope-intercept form, there would be a plus 0 after each one of them, making the y-intercept 0, 0, which is the origin. Now let's look at how you translate the phrase y varies directly as x. This phrase right here, every time you see that, you're going to translate it as equals k. So in this case, it says y varies directly as x. So you're going to write y equals k times x. So let's look at a few examples. Here's the one we just looked at. And remember, when you see the words varies directly as, we're going to translate that as equals k. So here I have y varies directly as x. Over here, here's that phrase again. So for this one I have p varies directly as q. For the next one, same phrase. So n varies directly as x. And then the last one, it's that same phrase, it translates the same way. So this will be w varies directly as t squared. These are examples of direct variation equations, and every single one of them has the same equals k in it, because the phrase varies directly as translates to equals k. Okay, here's a typical problem using direct variations. It says the variable y varies directly as x, and y equals 24 when x equals 6. Find the value of y when x equals 11. So the first thing we're going to do is we're going to look at this first sentence and the phrase within it right here. Y varies directly as x. So the first thing we're going to do is translate that. I've got y varies directly as x. Remember that varies directly as turns into equals k. Okay, now we're given a complete set of numbers. We are told that y equals 24 when x equals 6. So that means 24 equals k times 6. Well, we know to solve an equation for a variable, we divide. So we're going to divide both sides by 6, and I get 4 equals k, so I'm going to flip that and say k equals 4. Okay, so what that means is the equation for this variation, instead of y equals kx, it's y equals 4x. Okay, so now the next thing we're going to do is we're going to take a look at what we are asked to find in addition to that. It says find the value of y when x equals 11. So we're supposed to find the value of y when x equals 11. So we're going to take 11 and we're going to put it in for x. So that gives me y equals 4 times 11. And so my solution is y equals 44. Okay, let's look at another one. This one says, if n varies directly as z, and n equals 7 when z equals 21, find the value of n when z is 4. So we're going to do the same thing. We know that the phrase varies directly as is going to cause us to translate this as n varies directly as z. Okay, now I'm told that n is 7 when z is 21. Okay, let's fill in the rest of the numbers. So I've got 7 equals k times 21. So now be careful here because I am solving for k, which means I have to divide by 21. A lot of times students just automatically pick the smaller number and divide, but you need to keep in mind what you're solving for. We are solving for k, which means we need to divide both sides by 21. So that gives me 1/3 equals k, or rewritten, I could say k equals 1/3. Okay, that means my direct variation equation is n equals 1/3 times z. Okay, now you're told that z is 4. So if I put 4 in for z, I get n equals 1/3 times 4. So think of that as 4 over 1, and my solution is n equals 4/3. Okay, now let's look at inverse variations. That's a different type of variation. Again, look at the table, and what do you notice here should be that the product of the x and y for all of these is 20. So when that's true, where you have the x and the y values giving you the product that's the same number, in this case what we can do is we say the equation is y equals 20 divided by x, because 20 divided by 1 is 20, 20 divided by 2 is 10, 20 divided by 4 is 5, 20 divided by 10 is 2. Now this is called an inverse variation. We are going to attack these problems the exact same way that we did for direct variations, with one major change. When you see the words varies inversely as, you are going to translate that as equals k over. So when I say y varies inversely as x, I've got y varies inversely as x. So y varies inversely as x. So the only difference is instead of equals k times, it's equals k divided by. So in this first one, it's the one that we have looked at already. Y, here's that varies inversely as. So I've got y varies inversely as equals k over and then x. Okay, here's the next one. Here's that phrase again. So I've got p varies inversely as r. And for this one, I've got n varies inversely as m. And the last one, I've got w varies inversely as t cubed. So in every single instance, when you see varies inversely as, you write equals k over. So in this case, I've got y varies inversely as x, and y equals 8 when x equals 7. So find the value of y when x equals 2. So the first thing we need to do is look at this. Y varies inversely as x. We're going to translate it. Y varies inversely as x. We're going to fill in our two numbers. I've got 8 for y, and I've got 7 for x. Now when I solve this for k, I need to multiply both sides by 7. I get 56 equals k, or k equals 56. That means the equation for my inverse variation is y equals 56 divided by x. So now I'm told to find y when x equals 2. So that means I'm going to put 2 in here for x. When I do that, I get y equals 56 divided by 2. And that gives us 28. So that's the solution. Let's look at one more. This one, here's that phrase again, varies inversely as. So that's going to translate to y varies inversely as or equals k over x. I put my numbers in. I'm told that y equals 3 when x equals 8. So y equals 3 when x equals 8. I'm going to solve that for k by multiplying both sides by 8, and I get 24 equals k, or k equals 24. All right, that means my equation is y equals 24 divided by x. Now I'm told to put 10 in for x. So when I do that, I get y equals 24 over 10. And the best that you can do here is just simplify. I'm going to divide the top and the bottom by 2. And my final answer is y equals 12 over 5. Now there are a few special cases of variations. One is called joint variations and one is called combined variations. So a joint variation is going to have the wording varies jointly with. And if that's the case, you're going to translate that exactly the same thing, the same way as you do a direct variation. Because what it means is that y varies directly as, so equals k, and then it varies directly with two things, x and z. So when you see varies jointly with, you still write equals k. So over at this one, it says w varies jointly with, so I'm going to translate that as y equals k, and then the two variables are n and g squared. But I still have varies in jointly with, meaning the same thing as varies directly as, but I've just got two variables instead of one. And then it's possible to combine variations so that you've got direct variations and inverse variations in the same equation, or you could have joint variations and inverse variations together. So let's translate the first one. I've got varies directly as, so I'm going to translate that first one, y varies directly as x. And then it says inversely as z. So anything that's being inversely varied is going to go on the bottom. So the direct variation involves x, so x is on the top. The inverse variation has z, so that goes on the bottom. And then the last one, y varies jointly as, tells me I've got a direct variation. Inversely as tells me I've got an inverse variation. When I put them together, I've got y equals k times x and w, but then the z squared has to go in the denominator because it's an inverse variation. In this problem, it says the variable y varies jointly as x and z. So right away, when I see varies jointly as, I can translate this as y equals k times, and then x and z. So I'm given a complete set. Y is negative 108, x is negative 4, and z is 3. So I'm going to go ahead and put those in. Negative 108 equals k times x, which is negative 4, times z, which is 3. So I've got negative 108 equals negative 12 times k. So I'm just going to flip those sides so that the k term is on the left, and then I'm going to divide both sides by negative 12. And I end up with k equals a positive 9. That means my equation is y equals 9xz. Okay, so now I'm told to find y when x is 5 and z is negative 2. So I'm going to put those in, and I've got 9 times x, which is 5, times z, which is negative 2. And if I multiply those numbers together, I get negative 10 here times 9, which gives me negative 90 as my answer. Okay, here's our last problem. The variable y varies jointly as x and z and inversely with w. If y equals 3 when x equals 3, z equals 2, and w equals 4, find y when x equals 6, z equals 5, and w equals 15. Okay, the first thing we need to do is kind of look at this in 3 parts. Here's the first one. We need to translate this first sentence. The variable y varies jointly as x and z and inversely with w. So I'm going to translate that. Y varies jointly as x and z and inversely with w. So w goes on the bottom. Next, I need to look at the complete set of information that I'm given. I'm told the value of y, x, z, and w. So if I can put all 4 of those numbers in, so 3 for y, x is 3, z is 2, and w is 4. If I can fill in all the numbers but 1, I can solve for it. So when I solve this, I get 3 equals 6k over 4. And just to make this as simple as possible, I'm going to multiply both sides by 4. And that allows me to get 12 equals 6k. I'm going to swap sides, and then I'm going to divide by 6, and it looks like I've got k equals 2. So that means my variation equation is y equals 2xz over w. All right, now I'm told to let x be 6, z be 5, and w be 15. So when I put those numbers in, I've got y equals 2 times x, which is 6, times z, which is 5, and then divided by 15. If I multiply the numbers on top, I get 60, and 60 divided by 15 is 4. So my answer is 4.